Sue. Welcome everybody and thank you for joining us today. Today I'm going to talk with you a little bit about how to take your E1 system and make it a competitive advantage for your business. And we're going to do that through a discussion about mobile, its users, devices, and web portals. With that being said, let's kick it off. So today's goal is to get for you an understanding of the high-level approach of how to take E1 processes and make them available to the outside world. So on that topic then, well, what is the outside world? Well, basically, we see it as users on various devices, like we see today, phones and tablets, web pages, portals, and more recently, devices that can interact with JD Edwards to help us with the automation of some sort of process. So these are what we see more as called IoT devices. So today's talk is really going to be more of a high-level discussion for decision makers and not a tech deep dive. The following two webinars coming up are where we're going to get a little more into a tech deep dive and infrastructure deep dive of exactly how these tools work. So today is about learning, so learning kind of theory and how it works. So I would kind of keep that in the back of your mind as we go through today. So today we're going to talk about these key topics. First off, what is an AIS server? We're going to do an overview of how it works and how it allows external devices to talk to E1 logic and data. We're going to talk about usage scenarios. What are the different ways to communicate to that AIS server and make use of it? Next, we're going to talk about development options and frameworks, the different ways we can write code to work with this server and design applications, and what are the benefits and advantages. Implementation approaches will cover how we properly go about a project to implement this server and the type of technologies that you're going to run on it. It is a fair bit different than how other JDE projects work, so we want to be sure we give you a good understanding of what those differences are and how to approach it properly. And then finally, with the last few minutes we have, we'll do a quick Q&A, and we're going to do our best to keep this whole thing to about 45 minutes in length or less. Okay? So, onward and upward. So first off, what is an AIS server? Well, AIS stands for Application Interfaces Services. It's a piece of software that's built to run on Oracle WebLogic or the IBM WebSphere engines. So they're basically a web-based application. It installs a lot like an E1 HTML server. So if you've installed the HTML server through Server Manager, you've pretty much seen the whole installation process for an AIS server. It really looks and feels no different from that administrative perspective. But what does it actually do? Well, it actually, at its core, is an interpreter. An AIS server really is the interface between JD Edwards and the outside world, as we described it earlier, or as we say here, native mobile applications, hosted web applications, and Java programs. So all these different types of applications that we want to be able to talk to JD Edwards, the AIS server is that interpreter or that gateway that will allow that to happen. It uses some technology that you've maybe never heard of before called JSON over REST, which is really just the rules of how we're going to do that communication. And we're going to get into that in more depth in the next few slides. So, to dive a little deeper into AIS, it sits between your HTML server in JD Edwards and your phone. So in this graphic, you can kind of see the our one example of a cell phone up at the top, and our HTML server in JD Edwards at the bottom, and the AIS server sitting in the middle. And again, as I mentioned before, it acts like an interpreter, and it does a number of different jobs as this middleman in the process. It allows you to establish user sessions from all of these devices to JD Edwards. So just like when you would sit at a standard HTML client, you would have to provide a user ID and a password and you would log into JD Edwards. Well, the AAS server allows these external devices to establish those same type of sessions. And it keeps track of all the sessions and the users and what they're doing from the outside. It takes those requests for what we want to do in JD Edwards, interprets them into something that JD Edwards understands, and passes those requests on to the HTML server. Using AIS, you can basically perform any action with an application that you could if you were sitting in an HTML screen. So let me give you an example because I think it might clear up some of the things that we've just talked about. So imagine that you have an app that you've downloaded from maybe the Apple Store or Google Play. But imagine now that this app is for JD Edwards. So maybe it's a JD Edwards app that does something like purchase order approval or sales order approval. That app is going to have the ability to log into JD Edwards, so it's probably going to have a nice login screen. It's going to launch a particular app to do a particular function that we want it to do. It's probably going to have some fields on it and some buttons so that we can look up data, click a button to retrieve records or update the status of a record, things like that. Well, the apps that you build that talk to the AIS server look exactly like that. And as you put data in and interact with those screens and information is passed down to the AIS server is literally interacting with the HTML server in JD Edwards in the core app that you would use if you were logged into JD Edwards. So it literally is doing the work like you're sitting at a standard JD Edwards screen, even though back up at the top on your mobile device, the screen you have looks different. It's suited for mobile. It does the particular thing you want to do, but behind the scenes, it's still using the same core logic and functions of JD Edwards that you would be using if you were just sitting at a JD Edwards screen. So the other way I like to explain this to people is it would be kind of like if you wanted to do something like approve a purchase order, but you weren't at your computer and you phoned someone back at the office and you said, hey, can you give me a hand? Can you log into JD Edwards? Can you open this application? Can you find this purchase order or sales order? Can you go ahead and click this button to approve it and walk them through the steps? The AIS server is almost like that little person you're talking to on the phone. It's behaving in almost that identical approach or fashion, working in that fashion. So if that concept makes sense to you, then literally you're understanding the role that an AIS server plays as the middleman or the interpreter with this particular model. So in the beginning slide, I mentioned that the technology for communication is JSON over REST. So what exactly is JSON and REST? Well, let's take a quick look at that right now. So REST stands for Representational State Transfer, and it's just basically a method of communication between all these different types of devices in the AIS server. And JSON stands for JavaScript Object Notation, which is basically the language we use to communicate. So to boil this down to very simple terms, think of REST and JSON as the method we use to communicate back and forth and how we say what we say. So simply put, if I wanted to give you a piece of information, I could maybe get out a piece of paper and I could write in English exactly the things I wanted to say to you and hand you that piece of paper. The fact that I wrote everything in English is like JSON. That's the JSON aspect of it. And the piece of paper and handing you the piece of paper is like REST. So the method of handing you information and how I choose my words or how I communicate are really JSON and REST. The other example I use when I explain this to people is kind of like the postal service, you know. You sit down, You write a letter, put it in an envelope, you put a stamp on it and an address, and you put it in the mailbox. JSON is like what you wrote on the letter or what's written on the piece of paper, the instructions, and all the rest of it, the envelope, the address, the mail system that gets that all delivered, that really is represented in theory by REST. I mean, REST really doesn't handle the communication aspect of handing it back and forth, but it does all the rest. So I think if you conceptually understand those examples, you're getting at a high level what JSON and REST are all about. So with that basic understanding, we can take it a step further, and we can talk a little bit more in depth about what's going on and relate it back specifically to J.D. Edwards. So in this example here, we have a REST communication comprised of a request coming from a device and a response coming back from the AIS server after it's spoken to J.D. Edwards. If you look at the request on the left-hand side, you can see it's a request passing in a user ID, a password, an environment, a role, and then this thing called a device name. So if you're familiar with J.D. Edwards, you see those fields and you probably realize right away this looks like a request to log into J.D. Edwards with a highly secure user ID and password, and a device name, which is really just an identifier for the particular device so that the AIS server can say, hey, I know who you are uniquely compared to everybody else that I'm talking to. So if you're familiar with J.D. Edwards, there should be nothing too shocking there over on the left-hand side. Over on the right, the response received back is, again, information that if you've done any administrative work in J.D. Edwards probably shouldn't be too surprising to you. It's responding back with a user ID, environment, role, the name of the particular HTML server that I've communicated with, and some technical information that is needed for unique identification and rules of communication. So the token, which is basically a unique identifier for your particular session, a whole bunch of information about your user profile, which is in the F00921 system table, like your language preferences, your locale, how you want your dates formatted during your sessions, separators, decimal formats, on and on and on. Things that you would get if you just logged in normally to J.D. Edwards. And then so on, some additional information about cookies and so forth. So if you really break it down, nothing too shocking there. And what I want to point out is all this script you see here is JavaScript object notation or JSON. It's pretty easy, human readable information. Again, nothing too shocking once you really understand the rules going back and forth. Next, REST APIs. So we talked about how REST is our method of communication back and forth. Well, there's three core ways that we're going to talk back and forth to the AIS server. We're probably going to be making calls to particular J.D. Edwards applications. When we're working with those applications, we're going to be working with forms. So maybe we're going to be putting information on a form or clicking a button or interacting with fields and looking for requests and responses. Or we could be working directly with data in E1 tables or executing queries against those tables or business views. And so each of those takes the form of three different services that we make calls from using REST APIs. Then all the data that we request back and forth is in that JSON JavaScript format that we saw in the previous slide. So it's all pretty straightforward when you look at it that way. Another very quick example of some of these types of requests. These are form service requests. So here you can see, if you break it all down, a token up at the very top, a row of token information. If you think back 2 slides earlier, when we were doing the login request, we were assigned back a token, and that's the same token up there for our session. Now, if I take a look right at the very bottom, you'll see a form P01012 with a form of W01012B. That application is the address book application. Going back to the top, version ZJDE 0001, standard version. And we're doing some form actions. We're doing a command called set QBE value. So if you're familiar with QBEs, that's our filtering mechanism on a grid on a display screen. We're going to put a value of E, which in this case is employee, on a particular control, which is search type. And then we're going to do an additional command called do action on a different control, which is really just the primary action. In this case, it's a button, which is going to be the find button. So to say that all over again, we're going to go into the address book application. We're going to put an E on the search type field for employees, and we're going to click the find button. And it's going to filter out all the data on that form except those for employee records. So again, if you kind of step back and look at this, the concept's pretty straightforward, and the JavaScript, albeit you're not going to go out and write your own script tomorrow, but you could probably read this JavaScript and get a basic understanding of what is being requested here. And that's really the beauty of JSON over REST, is its simplicity. Okay, so we've covered off some basics of what an AIS server is, how it works and its function, and how its core technology works, which is JSON over REST. So next we're going to talk about development options. There's a number of different ways that you can interact with an AIS server, and we mentioned some of those at the beginning. Mobile devices, which we see all over the place today, websites and portals that are communicating from other more complex third-party systems, or maybe integrating JD Edwards into more complex pages that you have at your organization, and these new IoT internet devices that we see kind of gaining some traction all around the world now. So we're going to dive in and talk a little bit about each of these devices, from an offering like how Oracle offers you ways to talk to the AIS server, and how third-party or open-source solutions offer those same technologies. So we'll start with mobile devices, and we'll begin at that point. So from Oracle, they offer something to you for building mobile applications for mobile devices called the Mobile Application Framework, or MAF. It leverages Java, HTML5, and JavaScript, and it gives you the ability to build apps that you can put on a phone that can be compiled and deployed out to an iOS device or an Android device without having to write native code for either one. So you code it once and deploy it to many locations, and it will build you native applications that can run on devices using those operating systems. Okay. So it is really a development framework in a true sense. It's a place where you can write code and deploy it out. For it to run and to utilize it, well, you're going to have to be on a certain release of JD Edwards, version 9 or higher, with a certain tool set level, and you're going to need an AIS server. Now, the good news is an AIS server doesn't use a lot of resources. It deploys out as a web application. So it can even be put on existing servers if you're running an HTML server, provided you've got appropriate hardware resources underneath it to support it, or it can be run separately on its own virtual machine or physical system. So it's fairly straightforward from an architecture standpoint. As a developer, we mentioned in the previous slide that there's a framework for developing mobile apps. The one delivered by Oracle is called JDeveloper, and this is where you can actually design the screens that you want to build code for to put on your mobile phone or your mobile device. Additional to the tools that you get in JDeveloper, you need the JDE Mobile Application Framework and the math extension and helpers for JD Edwards. So what this really is, it's a lot of words there, but really at the end of the day, it's just pre-written code for JDeveloper for communicating to JD Edwards. You know, we have a number of different functions we know we're going to require no matter what you're writing in JD Edwards. Like, you're going to need the ability to log out and, or sorry, log in and log out of the software and do common things. So why not have some of that code just pre-written for you so you can just call it from existing libraries and classes and make use of it. You don't have to write it all from the ground up. And really, at the end of the day, these mobile application framework and extensions are really nothing more than that. Okay. Information about these requirements and these tools can be found in the guide release that I've mentioned at the bottom of the slide here. So if you want more information, you can get it from there. So writing mobile apps would take a long time to do from the ground up, and the JD Edwards team recognized that. So they pre-built a number of different applications for you. As of the time of this recording, there are 80 plus apps already built for interfacing with JD Edwards. These apps tend to be very small. I like to think of them as micro apps. They tend to all have one specific job flow or function. So you won't pull down an app for your mobile phone called, you know, purchase orders that does everything related to purchase orders. Instead, you may see something very micro, or a micro component of that, like, you know, approvals instead, and that would be its own app. So they tend to slice up apps into very small functions because really you've got limited real estate on most devices that are running mobile technology. So subsequently, they try to break up what you do into smaller screens that fit that real estate a little more effectively. So the 80 plus apps that Oracle has built so far in the JD Edwards team are really there to, are the most common apps that you would typically expect you would want when you're out and mobile. So they've tried their best guess to figure out what you would use and pre-write it for you. Those apps can be downloaded from the JD Edwards Update Center, and they're in the form of what we call Mobile Application Archives, or MAA. And they can be pulled in and used from the Update Center. And there are ways to extend and customize them, and we'll talk about that. In a minute. So when you extend or customize a mobile application, you're able to customize the branding that's on it. So all the Oracle logos, you can take them and replace them with the logos for your organization. The end user license agreements, if you have something a little different you need for your particular company. You can redesign some of the look and feel of some of the screens to make it a little more suitable for what you want. And you can display some additional data or add or remove fields of data from it and add brand new pages. But more fundamental code changes of how they function cannot be changed with these mobile application archives. They're really built off more of pristine JD Edwards applications. So unfortunately, that means if you've made significant customizations to your core JD Edwards programs, you may be looking at writing your own app versus taking one of the pre-written apps that they have and making some small changes to it. If you are going to make your own apps, you are going to need that mobile application framework that we talked about before. Licensing for that is done through something now called the Oracle Mobile Cloud Service, or MCS. So you're basically buying a license for mobile cloud from Oracle. It's a subscription service, and you pay so much a year to have it. But when you've bought that mobile service, you're not actually logging into the cloud to get any of the tools that you need. You're really pulling them in as a developer client and making use of those tools. So that's basically the option you have for creating your custom apps. Now, there is obviously some licensing costs when we get into these custom apps, whereas with the previous apps that we mentioned, the ones that are pre-delivered from Oracle, there is no cost. They are bundled and free and available to you. So you need to take that into account when you're making decisions as to whether you want to create custom apps or not using the mobile application framework. So what are the benefits of using MAP versus some other option, like some of the open source options that we're going to talk about a little bit later? Well, in theory, everything that you're working with, the developer tools, the AIS server, JD Edwards, all of it is from Oracle. So given that you're dealing with one vendor, it should all work together well and be certified to do so. It should be updated and tested together. It should lower your risk pretty significantly. And given that many mobile apps are already written for you, it should make your life a lot easier to extend and deploy those apps out. And again, it would lower your risk. Okay, you've got one vendor that you're depending on that's going to help you with everything and be thinking about all the interconnected relationships between all this technology. It should be more cost effective, again, because it's coming from one vendor. If you're able to use the apps that Oracle provides you, there should be no licensing cost. And fortunately, if you need to write your own apps, there is going to be a licensing cost for the mobile application framework through Mobile Cloud. And those prices can really vary depending on how many apps you make or how many users are going to be connected. And there's quite a complex combination of licensing options that are available to you there. And you'd really have to talk to your sales representative. I mean, I couldn't really capture it in this presentation. The other benefit is time to implement. It should mean a lot less time or complexity if you're using tools from one vendor or leveraging pre-written code that they've already provided you. So that's kind of a quick overview of what options you have for making mobile devices using Oracle tools. Next, we'll talk about websites and portals. And with them, we're going to jump into a very closely related but slightly different set of tools called the Simplified Application Development Framework, or ADF. So ADF leverages almost the exact same tools that we talked about for the mobile application framework. So really, this slide looks a lot like a slide you probably remember about 5 earlier. It leverages Java, HTML5, and JavaScript. You can build apps that can be deployed out using the same framework and the same approaches. So I'm going to skip through this slide pretty quickly. The architecture and development requirements are pretty much identical to what you saw earlier with the mobile application framework, because again, we're leveraging almost the exact same technology and tools again. The only difference is now, when we're developing screens, we're developing them to run as a component of a portal page or part of an HTML page, not something that's going to be presented on a mobile device. So it's pretty logical that Oracle would leverage all the same tools, technology, developer frameworks, and libraries in order to do both functions. Okay. So what are the ways to use this simplified application framework, or the ADF, Application Development Framework? Combining E1 and non-E1 data together on a website or portal is the most common usage that we see. So whether it's outside JD Edwards and you've got a portal page and you just want to pull some JD content in and maybe make it a frame of your portal page, or if you're inside JD Edwards and you want to pull external data in to augment an E1 page or interact with other E1 screens or build something like we call composite screens, combinations of JD Edwards data and external data all pulled together. All of these are perfect use cases for the application development framework. And inside core JD Edwards, if we just forget about everything we're talking about today, in the newest versions of EnterpriseOne, you're going to see examples of ADF being used on more complex screens. And you're going to see it all over the place. You're going to start seeing content being pulled into JDE for things like Google Maps and overlays and things like that that are using the application development framework. So the folks in Denver are not only trying to convince you to use this technology, they're actually making use of it themselves in the core product. So that should give you confidence of how well it works and that it's going to be supported and enabled in the future. So we have almost the identical set of benefits with SAF and ADF that we saw before with the mobile application framework. So I'll go through this fairly quickly in the interest of time. So we're looking at lower risk, lower cost, and lower time to implement solely because of the single vendor scenario that we talked about before, where all the products work together and are tested together. So next we're going to talk a little bit about these new internet devices. It's interesting, Oracle and the folks from Denver, from JD Edwards, are very, very excited about the future of internet devices and how it relates to your organizations. I haven't seen a lot of traction yet in the actual user community for these devices, but I do agree with them. I think it is coming over time. So this is a good area to understand at a high level and be thinking about in the back of your mind as you're working for your company, trying to find better ways to utilize JD Edwards. I think our goal with any piece of software like JDE and ERP systems is we should always be trying to get the most value we possibly can for every maintenance dollar that we spend with the vendor. So any way we can leverage this software and make it more effective and get more value for the business, we should always be looking for. And this is one particular area where a lot of people agree that in the next, let's say, 3 to 5 years, this is probably going to become a lot more relevant. So within JD Edwards, we have something called the E1 Orchestrator. And the Orchestrator is a set of tools to collect, filter, analyze, and act on data that's coming from all these little devices that we see in the world that may want to interact with JD Edwards. And those devices are really becoming so varied, it's really hard to even capture where they are and what they do. But I think we've all seen different examples of them, from simple things like wearables that we have today for watches and tracking fitness, all the way through to sensors that are used in more industrial type applications for measuring things like vibration or heat and cold, or GPSs for tracking the location of particular items, and so forth. So what is the orchestrator? Well, in short, the orchestrator is software written inside JD Edwards that is built specifically for us to allow these devices in the outside world to communicate back into JD Edwards. So when you listen to that, that sounds very similar to what we've talked about before, except this device is not a person with a phone in their hand working on a mobile device, or someone sitting at a portal screen, typing away. Instead, it's a small device doing a particular activity for a human being in their place, typically. So these tools are there to enable those devices to talk to JD Edwards. The method of communication is something we call an orchestration, or a bringing together of all these functions to do something in a coordinated fashion. So we're going to break apart all the pieces of Orchestrator, which are shown here, and talk about them one by one. And I think by doing so, it's going to make it a lot easier to understand what it is and how it works. Additional to that, I'm going to give you an example, kind of a real-world example that we're going to use to tie it back to the real world as we go. And in our particular example, it's going to be a truck. It's a truck delivering some product for you across the country. And inside that truck, it's probably got, let's say it's a transport, and it's got 16 wheels under it. I don't even know if that's right, so please don't beat me up if my knowledge of transports is weak. But it's got 16 wheels on it, and inside each tire is a pressure sensor. And it's basically monitoring to make sure that the pressure in the tire is at the normal or acceptable tolerance or level. And if it's not, then it's going to report back that there's a problem and that something needs to be done. So with that example in the back of our minds, let's look at all the different pieces of an orchestration and the orchestrator and get a better understanding of how it works. So first off, we described what an orchestration is. It's a process that identifies inputs for a particular activity that we want to do. So for our simple example, an orchestration in this case may be called tire pressure. So it's a monitor to make sure that the pressure in those tires is at an acceptable level. So with each of the 16 tires that I described on our truck driving across the country, each of those tires has one sensor inside of it. Each of those sensors has a particular ID to say, hey, I'm device in tire 1, I'm the device in tire 2, I'm the device in tire 3, and so forth. So each of those devices has something called a signature to identify itself uniquely. In JD Edwards, we have something called a whitelist. The whitelist verifies that when a message is coming in to JD Edwards through our AIS server, that it's coming from a device that we recognize. This is really important because we don't want to just accept messages from anybody, because someone could do some type of attack against us, a denial of service or some type of attack, if we accepted messages from anybody. So the whitelist really is just saying, here is the list of people that I will accept information from. Okay? So pretty simple. Each device has a signature, and the signatures we know about is our whitelist. Next is our rules engine. So basically, the rules engine says, here are the conditions for messages that I get from devices. And I basically measure those messages with true and false statements, and I can build complex logic from that. So our real-world example again, let's say that acceptable tire pressure for those tires on the truck is between 30 and 40 PSI, pounds per square inch of pressure. And if we get any variance outside of 30 to 40, then that's a problem. So with our rules engine, we could say basically anytime those devices report in a pressure, if it's between 30 and 40, then the answer, we basically say in our rules engine, this is a false message, meaning there's nothing we need to do. Everything is fine, just ignore it. But if the pressure falls below 30 or goes above 40, we could register a true. Something's going on. We now need to take some action based on that message. The complex thing about devices that are in the outside world is some devices are very intelligent and maybe would only send a message to you if the pressure was outside 30 to 40 psi. Other devices may just constantly be reporting to you, maybe every 30 seconds saying, here's my tire pressure, here's my tire pressure, here's my tire pressure. It may just constantly keep reporting. Some things like GPSs need to constantly report to you. It doesn't necessarily mean, though, that you need all the information. So the purpose of the rules engine is to really separate out all the extraneous noise, the information you don't need for this particular orchestration, versus the information that is relevant and the information that you want to take action against. So using our simple example, it becomes pretty clear why the rules engine is important. Next is the cross-reference. This is really just referencing IDs to something that E1 knows. So if we think of our example again of the truck, there's probably IDs for each particular sensor inside the tires. But maybe those sensor IDs are 30 digits long. But inside JD Edwards, we don't necessarily have a record of every sensor name, and maybe we don't even have a field that's 30 digits long that we can store it in. So that's a bit of a problem. Inside JD Edwards, we may be looking at that truck with the tires and saying, the truck is something I have an ID for. Or maybe each tire has an ID, but not necessarily the sensors. So cross-reference is really that relationship that says these devices are really talking about this particular thing in JD Edwards, whether it be the truck or the tires or some other identifier. So that's really the purpose of the cross-reference. It could be a one-to-many or many-to-many relationship back and forth. Okay? And then finally, the last piece, the service request. The ability to call a JD Edwards interactive application or an app via call to make something happen through the AIS server. So this is kind of the final step. This is where we want to take some form of action. So maybe we want to send a message to the driver about the tire pressure. Maybe we want to open some type of service request or repair request in JD Edwards, and we know we can do it through a particular app. So we want to launch that app, open a service request. Well, now we're just back to using the AIS server. Remember the AIS server at the very beginning? I said you could think of it like having, you're out in the field and you want to phone the office and ask a friend of yours to do some work on the HTML screen. This is really the same example. It's like the device could pick up the phone, call Sally at the office and say, hey Sally, found the problem. Could you please open a service request for this truck? And here's the details on it. And feed all that information in. Well, all of that information can feed in through the AIS server, just like we saw in the past, and do some action that you want performed in JD Edwards. So if you really step back now and think about that example and all the things we just learned, you can pretty much use Orchestrator to automate anything in JD Edwards that you want, whether it be internal or external. This is really a tool for enabling automation and workflow. The example we gave you is really for IoT devices because that's the context of what we're talking about today, right? How to communicate to the outside world with JD Edwards. But if you really expand your thinking on it, this technical capability is really much more far-reaching in terms of what it's able to do and how you can use it. So I strongly encourage you to kind of think about this more. I think there's really good use case applications for any type of organization, whether you're, small municipal city governments through to drug manufacturers through to, your true companies that are, building and manufacturing and distributing products. I think there's a lot of different use cases out there for this. So, orchestrations in terms of architecture requirements, well, you just got to be running JD Edwards at release 9 or higher in a particular tools level. There are some ESUs specific to getting the orchestrator working that you would need, and you'd need an AIS server. If you were developing more complex code, you'd need the AIS client as well, which is just a set of APIs. So what are the benefits of Orchestrator? Well, it's low risk, cost and time to implement. Again, all coming from one vendor, so the same benefits should exist as what we saw before. So we've covered off all the different ways that you can use JD Edwards tools for this external communication. Now let's talk a little bit about the open source options that are out there to you. Well, in short, there's a lot of them out there, a myriad of options available to you. And it's kind of like a funnel. There are many, many applications that you can write mobile apps for, or extend portals, or build device communication with. They're based on, most of them, on the code set of HTML5, JavaScript, and cascading style sheets, or CSS. They fall back into a smaller set of frameworks and toolkits that are available there from various vendors. And we've listed some there from Oracle, things like Oracle Jet, Bootstrap, Xamarin for Visual Studio, Microsoft development, The list goes on and on and on. And they all tend to go back to a compiler system, mostly one called Cordova, which allows you to develop apps and put them on devices. So to list out everything is far, beyond the scope of what we could talk about today. What we're going to show you in subsequent webinars is going to be examples of some of these more open source tools in action, how they work, and some of the things that we've built with them. So from an open source perspective, we can only really talk about what you need inside JD Edwards, because outside with these tools, it really just depends on which one you pick. But again, you have to be at release 9 or higher and at a particular tool set with an AIS server. And if you've got that in place, as long as your external tools are can communicate with JSON over REST, you pretty much have a method of communicating with JD Edwards through the AIS server using the kind of scriptable language and technology like you saw at the beginning of the presentation. So open source allows you to create these applications using whatever tool set you want, and using our APIs and communication methods through REST and JSON, you can pretty much have any type of communication to JD Edwards that you want. So what are the benefits of going open source then? Why would someone choose this? Well, maybe you've written a lot of, let's say, for example, mobile applications already in your company, and you want to keep leveraging all that investment in tools and knowledge, and you want to keep using your team. That might be a good reason to do it. Also, with a lot of open source products, because they're used so widely, there's a lower risk because there's a large pool of talent out there and a lot of information typically on the internet about how these tools work and how to use them effectively. And finally, in a lot of cases, open source means a lot less cost in terms of licensing. So there are a lot of benefits to look in this direction. You really have to weigh your own personal situation at your organization and say, does that make sense for me? Or am I better to be more risk averse and maybe go with a single vendor and know I'm going to pay a little more, but I've got a lot more protections built in because of that. We do a lot of work with companies in the consulting capacity to help you figure that out from a technology perspective. And we're always happy to help there. If you need to really understand what options are out there for open source and with Oracle and what is the right choice to make for your particular situation. So next, I want to talk a little bit about implementation approach, and I'll keep it fairly brief. When you're doing a project of this size, you really have to use a proper project methodology. You really shouldn't come into a project like this just thinking you're going to whip some apps together, publish them, and everything's going to be great. Apps take discipline, and that was certainly, I knew that, but I didn't know it until we started doing some of these projects, how much discipline it actually takes to design good, effective, impactful applications that are used either via the web or portal or mobile. So always have a proper methodology. I've just given an example of our ERP-One running right methodology that we use here that just kind of gives you a framework of all the different things you have to do when building a plan in order to cover off all the important areas. In terms of an implementation approach, you're going to hold discovery sessions. When you've done your discovery and know what you need to build, you're going to design, implement, test, document and train, and build support mechanisms for those applications. You're going to have a regular cadence of review, refresh, and extend for those apps, and a strategy for administering and keeping current the tools that you have in place. So very quickly, discovery sessions are made up of two key pieces. You've got your business needs and your tech needs. And this is what I was talking about earlier. Tech needs are picking the right tools for your organization for implementing mobile or implementing the outside tools to communicate to JD Edwards. Also, you've got to look at your business needs. where is this mobilization, or where is the external apps going to have the biggest impact for your organization or for your customers, your vendors? Where's it going to make the biggest difference? There's no sense writing 10 apps that are mildly beneficial to your company when there's one or two that could have a huge impact if you were to implement them properly. So it's important to do the analysis from both the business and the technical side and treat it as two separate streams of thinking, because they are very different. We typically help companies when we do something called a spin exercise, which is really just an organized meeting to figure out what your situation is, what problems you have, implications, and drive to needs. So where are you getting the best benefit from, the type of project that you want to undertake? You then are going to design your applications, implement or write code, and you're going to go through an iterative process of testing and recoding and testing and recoding if you do it properly. I can't say this enough. One of the most common mistakes I see out there is companies not engaging the people who will actually use the apps, whether it be your team or vendors or customers, and getting lots of feedback as you go. The ones that do this really well, do get them involved early and involve them in all the testing and take lots of feedback and understand it's a very iterative process. And if they do, they get a better result coming out the other end. So I can't stress that enough. Documentation, building a method of educating your users, educating the people who write code, educating people who maintain the systems that run this software, so that it all is understood and can be used correctly. Training approaches and scheduling. Once you've got this app built and tested and your core group likes it, making sure that everybody who uses it knows how to use it correctly, so that so that it works well for them, because they're not using it incorrectly or misunderstanding it. And then finally, building all your support methods of keeping the software relevant, current, working, and effective. Review, refresh, extend, plainly stated, is an app, once it's written, will need to be looked at on a regular basis. I'm not saying constantly, but let's say once a year, for example. You're going to want to go back and look at the app and ask yourself, is it still doing everything we need it to do? Has the business changed and the app needs to change to go with it? Do the users, after using it for a year, realize there's 5 additional things we wish this app could do, and if you could add that functionality, it would make it far more effective? Or after using it for a while, we realize that we could make the app a little better by just changing a few small things, like where this field is on the screen, or maybe this drop down could be a button instead. Little things like that. So review, refresh, extend is really about that, going back and revisiting and improving to keep things moving forward. And then finally, on the tools and administration side, it can never be assumed that the people you have at your site know what an AIS server is, know how to apply tools releases, know how to update the AIS server. So how to do things and when to do it cannot just be assumed. You should have plans in place for documenting and making sure people understand the documentation, because you're going to have staff turnover, you're going to have hardware and software updates that need to be applied. So you're going to want to be sure that it's known how to do those updates and it's documented, and that you want to also know that there's documentation on how to maintain these systems and troubleshoot issues. But you're also going to want to be sure that the people reading those documents understand it. You know, the worst thing that could happen is you have perfect documentation, but then a person who doesn't understand it because they just got dropped into this job. So revisiting that on a regular schedule and having a strategy for that means that you're on top of things and that you're not going to get any unwelcome surprises. All right, so this was a bit longer than I'd hoped. I'd hoped to get through it in 45 minutes, but we came closer to an hour, so I apologize. The good news is this first lecture is really more of our theory lecture. The other ones are much more hands-on and visual and with tools. So hopefully you don't mind that I went over a little bit on this. So at this point, I just wanted to open it up to the group if there were any questions that anyone had related to this. I'm looking in the Q&A box and I'm not seeing anything in there right now. So I'm assuming there's not, but I'll give it a few more seconds here to see if anyone had questions. Well, wonderful. Well, I guess on behalf of our company, I wanted to thank you for attending today. I hope you'll make it to the second and third installment of this webinar series. I hope you found the information valuable and you enjoyed the session. And we'll be sending you out a copy of the slides. And I guess have a great day, and we'll talk to you soon.